Hi, my name is Ellie Webb, and I'm 10 years old, and I have a question for Blue Sky Science. It is, how does the moon affect the tide?
Hi, I'm Grant Petty. I'm a professor of atmospheric science in the Department of Atmospheric and Oceanic Sciences at UW-Madison. Okay, to talk about the tides, I have to talk first about gravity, because gravity is what makes tides happen. Now, gravity is the attractive force that all matter exerts on other matter. And we know that we have gravity because gravity holds us to the Earth. We don't fly into space. It also pulls the Earth together into a ball. All of the mass, all of the matter that makes up the Earth attracts each other, and the result is that it pulls itself into this nice round ball, which we know of as the globe. Now, if that's all that was going on, we'd have a smooth, round sphere, and the oceans, if they covered the entire Earth, would be the same depth everywhere and would never change. But because we have a moon as well, the effect of that is to bulge the ocean out a little bit here, and out a little bit here, and to lower it on the sides. So the tides are the result of the moon exerting its gravitational force on the ocean and bulging it both toward and away from the moon. So the tide is higher, the ocean is higher at that location close to the moon and on the opposite side. Now the Earth also rotates, and as the Earth rotates, the position relative to the moon changes, so the bulge moves, and at any one location, the sea level goes up and goes down as the bulge passes that location. So every 6 hours, the tide goes from high to back to low again, and then back to high 6 hours after that. And over 24 hours, you typically see 2 highs and 2 lows. So that's the effect of the moon and the rotation of the Earth on the tides. You also have the influence of the sun. The sun, if it happens to be aligned with the moon, also exerts a gravitational force, and it can work together with the moon to make the tide even stronger on the side toward and away from the moon and sun. Or, if we put the sun to one side, then it works against the tide of the moon and reduces the high tide and raises the low tide a little bit so that the peak and valley is not quite as large. That's what we could call a neap tide. When they work together, we call it a spring tide. Now, things are more complicated than that because the oceans have a shape, they have different depths, they have coastlines that are complicated, and so the water sloshes around in ways that causes the sea level to rise and lower by different amounts depending on where you are, and sometimes at different times relative to when the moon is overhead. So there are locations like the Bay of Fundy in Canada where the sea level variation from low to high is as much as 50 feet, whereas much of the rest of the world, it's only a few feet up and down with each high and low tide.